Fieldwork number 6, Trigonometric Leveling. Objectives: to acquire and develop the skills of determining the vertical distance of a remote point by applying trigonometric and related analysis. To develop the skills of reading vertical angles using theodolite or total station. Instruments and accessories: theodolite, leveling rod, markers such as chalk or marking pins, measuring tape, plumb bobs, range pole. Procedure: set up the theodolite at a convenient location and call it point A where the leveling rod and the remote point are visible. Using the telescope, take a side at the topmost remote point, then read the vertical angle. Record this as alpha on Table 5, Trigonometric Leveling. Take another side for the second triad. This is done to determine the precision of the observations. Then, calculate the mean of the two vertical angles or the angle of elevation of the specified point from the first station. To get the mean, alpha is equal to the sum of the two vertical angles from the two trials divided by 2. Set the leveling staff or rod vertically near the base of the remote point and take the level foresight on the rod to determine the height of the instrument. Now, transfer the theodolite towards the location of the remote point and designate it as station B, then measure its distance by taping from its initial position. Record this as distance AB. After centering the bubble of the instrument, sight at the same topmost remote point twice using the telescope. Record as beta on table number 5, trigonometric leveling. After recording these two observations of vertical angle, calculate the mean. To get the mean, beta is equal to the sum of the two vertical angles divided by 2. Now, level the telescope while at B and get the height of the instrument by sighting the same leveling rod near the base of the remote point. Then, analyze. See the figure below. The right triangles formed to determine the height of the remote point. This fieldwork will not consider the effects of the combined correction of Earth's curvature and refraction. Analysis of the figure. First, determine the distance in elevation between two instrument setups by subtracting H2 from H1. Next, consider triangle B'EF, then solve for the distance x using the tangent function. With the formula, tangent beta is equal to the difference of H1 and H2 divided by the distance x. Determine the sum of the distance AB and distance x for the analysis of the oblique triangle A'FD, which is just equal to AB plus x. Consider triangle A'FD and use sine law to determine the distance FD. With this formula, simplifying this formula, FD will be equal to the sum of AB plus x multiplied by the sine of alpha divided by the sine of the difference of beta and alpha. Consider triangle FDG and determine the height of the remote point DG. By the formula, sine beta is equal to h minus h1 divided by the distance FD. That's all for the fieldwork number 6. Thanks for watching!